Are you coming to the user group next week?
Who, me?
Yeah, you.
Is there a user group next week?
Yes, I'm going to talk.
You're going to talk?
How am I else to talk? I got to talk myself.
Oh, I don't know. I might have something to do that night.
I know. I figured you weren't coming.
What are you talking about?
Software craftsmanship.
Oh.
Talking in Philly a few weeks ago, a few months, years ago, whatever that was. I don't know. I went through all my talks. Like I don't feel like making a new one, which was something that I can do again. So I'm like, fuck it. That's the one. That was my fallback when I didn't know if you could do last month.
Yeah.
You're like, no, I can't do it. I'm like 2 days later. You want to come speak? Oh yeah, sure. I'm like, thank God.
All right, Chris, you ready?
That's a fallback.
Chris, the internet is watching.
Oh, are they?
Ooh.
Hi, internet.
Hi.
Nobody's actually watching. You know that, right?
The internet is watching.
Oh.
This is being recorded
everyone
for
and no one. Right.
Someone will Google 20 years from now or 15 years ago about separation concern and find this video, and they'd be totally lost and confused.
Yeah, they'll be like, "What? We're all functional programmers now." We're all
functional programming is
that's not.
Move on. That's fake programming.
They did a whole show on nulls?
Yes.
What?
I want meta programming. Forget this freaking functional programming.
Waiting on you, Chris.
All right, I'm ready.
Ready? All right.
20 seconds time.
3, 2, 1, go. Hello, and welcome to the Static Void Podcast. I'm Jess Chadwick.
I'm Todd Snyder.
And I'm Chris Gomez.
And we are your hosts. We are recording this on the evening of October 2nd, 2017. And tonight we're going to cover a topic that has been haunting us our entire careers.
For Halloween.
Yeah, it's our special Halloween episode. You know what? All three of us has had pretty strong opinions about what clean code means. Surprising, I know. And all three of us has over-engineered something, and as well as called something over-engineered. So today we're going to be talking about what does that even mean? What is over-engineering? How do you know when you've done it? And how can you avoid it? Maybe. I don't know. Todd, you ever over-engineered anything?
Never. Of course, anyone does, right? Particularly when you first learn like a new pattern or even a new framework or something. You're like, I got to figure out how everything works. So I'm going to start including everything in here. Let me add dependency injection. Let me add solid. Let me do all these things. And all you really needed was something that printed out hello world or something that's parsed the file. So I always laugh. There's actually a website that's dedicated to all the different variations of creating hello world. And there's examples up there, like 45 classes to create hello world. It's the ultimate example of how do you over-engineer something.
Yeah. I think I saw recently somebody did a comic where they say the beginning programmer, and it's just like you said, it's just the one-line hello world, and then after 2 years, and they put it in classes, and after 4 years, they've used the interface, and then after 6 years, they added some attributes, and after 8 years, it's a huge solution with projects, and then after 10 years, it's back to just the one-line hello.
That's great. I've never seen that.
I have to go find that. That was pretty funny.
All the code's coming out except the one hello world.
Yeah, they just put it all back. So yeah, this comes up a lot on the job, I think, because somebody at work maybe has learned a few design patterns and applies them to a project, and unfortunately, the rest of the team looks at it and goes, "What did you do? I don't get it."
And this is very opinionated, right? I think every time someone says the word over-engineering, it's very much based in their experience.
Yeah, I mean, by definition, right? It's a subjective term, and it's what. So if something is over-engineered, what is under-engineered? What is properly engineered, right? Like, where is that? What is the goal there, right?
Well, first of all, so why do we do more than just bang out one by one the steps to solve the immediate problem? And usually the answer is because we know with a little bit of experience under your belt as a professional developer,
AKA pain.
right? A little bit of pain. You know that if you just did that, that sure enough, come Monday morning,
Yep.
there's change.
Yep.
Change has come. And so, so after a little bit of experience of like hacking a bunch of code, you start saying, hey, I'm going to protect myself from this.
So I've noticed in my career, I've worked for a variety of sizes of companies, from like 2-man startups to like right now I'm in a literally 200,000 person company, right? And I get accused of over engineering at the smaller organizations, and then at the big giant enterprises, it always seems to be a pretty good solution. It always seems to be about right. I don't think I've ever been accused of over engineering something at the big enterprise. And in fact, most of the complaints of the developers around me are that something is, flaky, that is not standing up to the test of time, and it's very difficult to work with over time as that enterprise application grows and grows and grows.
Mm-hmm. Do you get accused of maybe too simple a design, or does that on it totally different thing? Like, hey, enterprise, why are you making this so simple? You're not thinking of all the possible problems.
No, I've never been accused of that in any size company.
That's good.
Making something too simple. Yeah. You just get accused of it doesn't work or it's, difficult to extend.
Yeah.
I've never been accused of making something simple. I've been accused of making something, what's the word that they would use? Difficult to extend. They didn't say it that way. I'm trying to remember what they said, but yeah, I mean, it's frustrating when you go and try and add a new feature and you can't because you have to completely rewrite the code, refactor the code. Refactor if you're being nice, rewrite if you're just being truthful.
Right. If only you were just refactoring it, right?
Right.
Because I think that's one thing a lot of people that we have a real hard time with how we've overloaded that word. It has a real meaning. A refactoring is a mathematical change to your code.
Yeah.
You should be able to pull it off the shelf. In fact, probably from like Fowler's book, right? Martin Fowler's book, Refactoring, and say, we are doing this refactoring.
Yes.
This is the reason why these are the things. I think a lot of times what it comes down to, and this is something that I know I still struggle with, is about discipline, right? Being able to look at a bunch of code and say, is this good enough? Or what are the problems with it? And if you identify problems, being willing to change it and make the investment in changing it. I think what ends up happening over time, you talked about the big enterprise. I think that I've seen this in the bigger enterprise more than the smaller companies. Once something's deployed, people are afraid to touch it.
Yeah.
And what happens is you use, no matter how hard you don't try, everybody's using patterns in some capacity in modern development, right? Classes by themselves is a pattern. People start duct taping on all this other stuff on top to try to hide the mess. And ultimately what they do is, while they're actually doing good practices in general, what they create is a clusterfuck, right? End up so many layers of stuff on it. Eventually, like, well, I'm just going to start from scratch again, or I have to totally replace all this. When I think the trick really is TDD, right? If you follow the true tenet of test-driven development, you're only writing the tests for the problems you're trying to solve today. So if you have that discipline of, I'm going to create a test, I'm going to create the software that meets this test need, I think you're less likely to fall into the trap of trying to build extra stuff because you're not going to write those tests until you need them, or you shouldn't write those.
Yeah, I mean, I agree to a certain extent. In that, I'll kind of come the other way at it. When I really started truly deeply understanding what unit testing is, TDD, why the dogmatic folks are so dogmatic about TDD, truly test first development, was because I saw the effect that it had on the design of my code. Just practicing TDD and writing testable code, having to write testable code, meaning having to test your code, and therefore having to make that code testable, kind of inherently made it cleaner, more decoupled, more specifically, right? So
Definitely
that you could mock things out. Yeah, and that decoupling seems to be at the root of a lot of this stuff, a lot of clean code, a lot of the patterns. But that said, I mean, isn't that even that couldn't? I mean, that's been called engineering. You know, like even just
Yes.
trying to decouple something, decoupling kind of at the root of it is taking some logic and like separating it, right?
Yeah.
Decoupling it.
Yep,
When
definition.
yeah, a lot of people and people have accused me of this of over engineering something that was one thing, and I took it apart, and what I thought I was making those two things more cohesive and independent and separation of concerns and single responsibility principle, you know, all the solid principles. That's what I thought I was doing. And whether I was or not, you know, I really still do think I was doing it, but whether I was or not, they had a very legitimate concern that I was over engineering because it was simpler when it was just in that one place. It was easy to read. It was these 10 lines that you could just go through, pop, 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 pop. Here, you know, you just read it right like a story, one
Like a
through
checklist,
10.
yeah.
Like a checklist. Yeah. And you don't have to go anywhere. That's a really legitimate concern. And so that's why I've always struggled with this problem, is because I've seen loose coupling really, really come in handy. You know, like
Yes.
I have implemented loosely coupled patterns where, like a data access thing, and you do a nice job of separating that data access, and then you literally just wrap it with a caching layer, you know, because it is truly just an interface, and those separation of concerns were abstracted enough that you could just throw a caching layer in the middle, and the consumer of that data access layer just doesn't even notice that anything has changed.
Right.
And the actual implementation of the data access doesn't change. It makes the live call every single time it's called, and then you just throw that caching layer in the middle, and, you know, and like it's a beautiful thing when you do that. And
Right.
it is truly just, hey, I just added that in, you know, problem solved. I'm going home, spent my 8 hours as opposed to 3 weeks rewriting the thing.
Yeah. I think the trick is, and actually give a pretty good example of something I've over-engineered, and I'm afraid I would do it again. Everyone ever work with the security principle in .NET, and you want to get the username? You have to dig in like 6 dots. And I remember once coming across the same code 500 times with principal dot Windows identity dot this dot get the username, and I'm like, that's just wrong. So I ended up creating this class to wrap it, and ended up creating 3 lines of code where you only needed 1 line of code, just to avoid having that dot 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 everywhere.
Yeah.
So in that case, pretty much it was over engineering, but at the time it's like, I'm tired of seeing the same code. It's not, we're tying ourselves too coupled to the Windows principle, when later on we actually needed to get away from that. At the time we didn't. My motivation was simply I got tired of seeing all the dot dots. But later on it worked out that we had to get away from the Windows principle, so it kind of worked. It was a benefit, but that was not my motivation.
Well, and the dot dot is an anti-pattern itself, right? What is it, the law of Demeter, right? Where you really shouldn't be digging that far into your dependencies, because now you're looking at their implementation, basically. If I'm paraphrasing,
Okay.
you
Yeah,
know,
we
but
gotta
like
get the
too
definition
much
of the
about
law
their
of Demeter, right?
Yeah.
Yeah,
Well,
right.
One of
'Cause
the
I've you know I've used the term, and we've heard the term. So each unit should only have limited knowledge about other units. And
Mhm.
you're right, when you have to dot into an object multiple layers, that means you as the consumer know intimately how that object must work,
By
because
definition, the internals of that thing.
yeah, because you've
Yeah.
said, like, let's take something like system URI, right? Well, if I'm dotting in to get the host, well then heck, that means I know that system URI is encapsulating the definition of a URI, and I can pull just the host out.
Mhm.
But then
So I
again,
gotta
that's
say,
useful though, right? Isn't that useful? I'm, instead of me having to write a bunch of code to
right.
take URI apart, now so how is that not violating it? That's, now I'm using it as a tool, like a Swiss Army knife.
Yeah.
Well, maybe not a Swiss Army knife, like a Leatherman. It's a good
Yeah.
tool.
I think the trick
I
is
want to
how you
decompose
extract
the
it.
URI. Okay.
In my case, I was creating I made you write 3 lines of code. Well, maybe it was this in a base class, it would have been cleaner, right? There are different pros and cons to how you tackle the problem.
But
In
no,
my
you just
case,
said a base class. That's another kind of
well, that's
engineering,
potentially, yeah.
over or not. Yeah.
And another one, like a lot of people don't talk about this, is too many classes, right? If you read the Martin Fowler book, one of the code smells, he kind of tackles both sides, right? You have a class with too much responsibility, and you have a class with not enough responsibility.
Yeah.
Right? We were talking before about Razor Pages with the idea of that having a controller, this is a pass-through. There's no value in having that class. It's just 1 line of code, and when there's 1 line of code, what do you want to do? I want to write a test. Now all of a sudden you write all this time writing a test for 1 line of code that just works, right? You don't need all that extra infrastructure. So I think that we were talking about this before, right? board balance. And to me, this is the tricky part. That's why I started with the word discipline. You got to be disciplined to find the right balance for your problem. The next project, the next 20 lines of code you write, you might need a different balance. There isn't this great silver bullet that says, I will always use single responsibility and all the solid principles, and it will always follow this line of code. Because sometimes you just need 3 lines of code and just be done with it.
Yeah, so there's so 2 competing principles here, right? At the beginning of extreme programming, a common term was YAGNI. You aren't going to need it. And even before extreme programming, I think Steve McConnell wrote in Code Complete about gold plating.
Yes, there definitely were some.
Don't gold plate your code. Don't meet non-requirements. So those two concepts go hand in hand, but then balance that with the idea of having flexible, robust, and extensible software. How do you balance it? Where's the scale? Can I buy a scale at the software store such that I can now balance these concepts and get it right?
Oh, you can. You can buy the scale, and yours is in metric units, and then mine is in standard. I'll buy a different scale, and mine will be in standard units, and then we'll have another problem.
So is it an art, or are there are there principles we can use, or is it just an art? And Jess happens to be pretty good at getting it right. He has a great intuition about it. Now, how scary is that? I'm not.
Are you mocking me? I don't.
No, I'm not. I'm just kind of using you as an example. So you have someone who's a great they're a great software architect. Why are they a great software architect? They just always seem to build just what we need. So is it just that they have?
Or they're hell great at selling the solution. This is exactly what you need.
Yeah, there you go.
Maybe
they're like great at convincing you that they made what you needed.
That's called consulting.
People like that just have a great intuition about software, and they sort of can look at the business, and maybe they can't explain how they do it, but they sort of say, I think this is about the amount of flexibility that we need, and any more than that we'd be literally wasting the business's money.
Well, and there it is, right? I mean, and that is a serious risk there that you go through with all the over engineering. It costs more to maintain that software, right? We implement these things to lower the cost of maintaining the software, right? That's the whole point of this. Loose coupling and solid principles and everything make it easier to extend, easier to maintain this application. But then when you cross that line, that invisible line, that balance, where can't even figure out where it is, now all of a sudden that application becomes more costly to maintain and fix, or just to write in the first place, because you've written that gold plating code, right? You've written too much, and now, first of all, it cost you to write that code, and now it will cost you forever more to maintain that code, and God forbid it goes and actually breaks. That code that you don't even need starts breaking. Mm-hmm. And breaking other stuff that you do need later on. It becomes an actual liability. So, I was
going to say, or what you end up doing is when you go to do the next requirement, you're like, this is so over-engineered, I'm just going to build another abstraction on top of it.
Right. Right.
I think it's very easy to fall not in success, right? It's very easy when you get the right software. Because I can tell you right now, I'd rather have over-engineered code, I get refactor, the function that has 3,000 lines in all one file. I run that a whole lot more than I over-engineered something. Because to me, if you over-engineer something and you follow well-known patterns and things, you can kind of figure out why they may have done that. In some cases, it's not always clear. When you have 3,000 lines of code in one file, that's just poor development. That's just poor practice.
But you can read it all in one file, and I'm half joking. Like that's a legitimate answer. It's all there and you can read it. Yes, you got to scroll, and that's a pain and that's a problem, but it's all there, and I'm not arguing for that approach. I'm just
except when you have 20 developers all working on the same file and checking the same file.
Right. Yes. No, that's a different problem. It's a very, very legitimate problem, but that's a different problem. So there are other reasons other than just, loose coupling and everything that you want to split things up into different files. I mean, there's, source control and other kind of technical issues, team collaboration issues. But Chris, going back to, you call me out for, potentially making good stuff. This is a
could've
very
gone
awkward
on.
situation for
I
me.
could have. Let's just talk about an architect, John.
So some
What was it?
architect, yeah, some architect who's not me. This architect you're praising, and they have been called an over architect. You know, their
Yeah,
solutions in
sure.
the past have been called over architecture, and I think that's a very interesting thing. And it may literally be the same solution that you call very well architected. I really like how this is going to help us, and it's exactly what we need. And Todd says, "Come on, this is ridiculous. This is way more
Right.
than we need." Right? And I think we joked about being able to sell it. I do think that's a part of it, not selling it, but explaining it.
Yeah,
Because
well,
it is very much, code cannot stand by itself. It has to have that story. You have to know that story. You can't just come up and start judging code. You have to really understand how it came about, what problem it's trying to solve, and how it's trying to solve it. That may or may not be the correct solution, but it was a solution that someone put in place for a reason. They didn't just throw some code against the wall and that was what stuck.
So a concrete example. Um, data, like just data abstraction libraries or things like Hibernate or Entity Framework, although maybe Entity Framework's not a good example, where they supposedly support many different types of data stores.
Mhm.
And so one of the selling points on some slide somewhere is that, when we decide to move from SQL Server to Oracle,
Yes.
we won't have to rewrite a bunch of code.
Yes.
And then when in your career has that decision
Right.
ever been
I've made that claim too. And literally as I'm saying the words, I'm like, we're never going to do this.
right?
But it's the point of it. I mean,
Yeah. Well, I was going to say at the same time, here's the flip side. Okay. So let's take that ridiculous talking point, but let's add one that's actually a little bit more relevant, which is, no, the reason why we really wanted to couple here, and we don't want the consumer, the host of the application, to really care where data is actually coming from, is because it allows us to say, well, let's not get it from SQL Server. Let's just keep it in memory. We'll build an
Or
Uber
cache,
box.
Jeff said.
Well,
Yes.
I was just going to get to wrapping a cache around it. Or, well, heck, if we had a 64 gig box, we wouldn't need anything.
So the way that I've begun presenting those scenarios is, I'm not saying we will someday need to switch our persistence layer. What I say is, when we are able to switch our persistence layer by just implementing another class or whatever, that means we've decoupled it correctly. We have separated those concerns and they're no longer leaking everywhere. And back to your point earlier about, coming up with a good solution, that's kind of the rule that I generally go against, is when these things can stand independently and be switched out from one another, then they're properly separated.
And persistence
Yeah.
is one of the areas I think that it's very clear, right? We've all been in this industry almost 20 years or so. That keeps changing, right? We haven't found the perfect solution to that one. And every few years, you're going to plug in something differently. Even though you may not switch to SQL Server or whatever, you may I need a new version of any framework, or I want any framework core now, or I want to switch record sets, data sets.
Yeah.
That's going to happen. So by using abstraction, what you've done is you've isolated the change. And that's really what you want. It comes back to, let's get back to our discipline. Being able to disciplinedly say, you know what, there's a good chance this code needs a change. It may or may not change, but the likelihood is high. So by isolating it, I know I'm gaining that benefit. Again, when you get back to test-driven development, most likely you want to do that anyhow because data is it's not memory, right? You want to test stuff that's in memory versus persistence. So you have to kind of. I think the balance really is about pros and cons. Here's all the pros for doing this. Here are all the cons for doing it. And do they make sense?
Do you make that list?
Sometimes I do, yeah.
Okay.
As an architect, I do.
Okay. That's actually insightful, because how many of us do? How many of us, I think that we should probably put this in a class library and maybe think of create an interface. That's the extent of the pros and cons list. It's not, you're talking about a concrete list here. I think that might be a good tip.
And I think because of my experience working with a lot of different customers, I try not to say I already have the solution. I try to justify the solution to myself. I try not to say, well, I already solved this problem, so I'm just going to do X. No, I try to go in blind so that I force myself to move towards the solution as to saying, I already got it figured out.
That's that's actually, I don't want to gloss over that. That is a really good way to approach problems, especially when you're talking about new frameworks and platforms and
Yeah.
things, right? Because I have seen plenty of solutions. This isn't even necessarily related to over engineering or not, but plenty of solutions where people have migrated from platforms and they've just tried to re-implement the stuff that they had done in other platforms without taking into consideration the new capabilities or basically just the fundamental differences in the platforms. And that solution that they made for that other platform is just not the correct one, or at least not the best one.
Or even even in .NET. .NET's changed so much from .NET 2.0 to something else. I've recently came across some code where someone was still using an array list, and I'm like, what?
Yeah.
We have generics now. We don't need to use array lists. And then I was able to convince them, here's all the problem, the boxing, whatever. I'm like, oh, I didn't even realize that. I'm like, it's just because they had already something working, they continue to use that approach.
Yeah.
So this guy, I bet, is selling, right? This is part of the selling process. Internally, as a good architect, you should sell yourself first. Don't just go in and say, I have this grand solution. Because then your likelihood you're going to over-engineering. If you're convincing yourself as you do things, to me, you find the right balance, at least for yourself. Go ahead, Chris. I was interrupting you.
No, I mean, so you mentioned we're talking about over-engineering. So the warning signs, are there warning signs? Hey, I'm doing too much. This is really, maybe it's okay. For example, lean development, minimum viable product, get to market quickly. But if we contrast that with maybe some advice, I'll pick on Robert Martin, on Uncle Bob. He would say, if your code isn't clean, you create the ball of mud. And so version 1, you've got it out there, but the code's not clean. So version 2, you've got some kind of crappy code in there, and you code and fix, and you patch and fix, and now you're heading towards something that is taking longer and longer to add features to. I mean, I have been there with products where it's unbearably hard to do the simplest things, and it's even more depressing when perhaps the business begins to figure that out. That we ask our developers to do the simplest things, and it just seems to be a slog, and they get lost. And heck, sometimes they might blame the developers, but other times what you do is you just stop making changes. Like, let's not change anything.
So there's a couple of things. First of all, clean code. I don't know if you've read the book Clean Code, but Robert Martin goes through and he takes I don't know what the original piece of code is, but it's basically one function, maybe 20 lines of code or something. I don't know, something like along those lines. And he deconstructs it. And by the end of the book, he is at like 4 pages and like 30 classes, and none of them are more than like 2 lines long.
Right. And one parameter for each function call, right?
Yes. And I'm like, that is over-engineered. I mean, that's like, you read that book, that is the definition of over-engineered. Clearly, he doesn't think so. Clearly, many other people think that is kind of the right way. I think at some point in that book, and I still can't point to the page where it crosses the balance, but at some point in that book, it becomes over-engineered. I can agree that it starts out with, quote, messy code, bad code, whatever you want to call it. And it progresses through a set of kind of practices and applying some theories and things to these things, some refactorings, as you said, and at some point it becomes about right, and then it goes too far. I don't think that was his point, but
what makes it really hard in a book, I think, or as a teacher, or to think about this abstractly, is there has to be skin in the game. So that means money. That means business.
Sure.
I guess it doesn't have to be money, but the key is, in a real project where you are trying to satisfy a real stakeholder, and that could be yourself, but it could also be you're a consultant. It could be your
external
boss,
body, somebody who's giving you requirements.
Somebody who's going to say, I think you've got it right.
Yeah.
Now we have that real ability to say, okay, are we doing too much to solve the problem, or is it solved now? We're in a book like Clean Code. He just keeps going. Let's just keep building the road until we finish the book.
Yeah, that's MVP. I mean, you keep talking about MVP, right? And MVP it's the minimum viable. Like, what is the absolute minimum that you can do in order to satisfy the problem, the request, or more importantly, make people think that you're solving it. Right? And that may involve some tech debt, right? Like, that may involve some shortcuts that you're very aware of when you make them. and you know the first thing you do is you're going to go back and pay down that debt, fix those issues. But you have to. I mean, that's the biggest problem. It's not that you write crappy code in the beginning. It's that, because I've written plenty of code that I know is crappy, but I fully intend the next time around to go and clean that up. And you have to be disciplined. And when you're talking about money and estimation, you have to estimate that, right? Like you say, yes, in order to deliver this new feature, it's going to cost me 2 man months. I'm not telling you that a half a man month is cleaning up the other stuff, because it doesn't matter to you. You know, it will take me 2 man months.
Yeah, exactly.
Okay.
I think
technical debt is the cost under engineering.
You have.
I was going to say, actually, I think over engineering is also a technical debt.
Okay, sure.
Yeah.
I expected someone to say that.
Yeah, to me, and it's really difficult. I want to build upon what something Jess has said, because I've run into this quite a few times. When you're trying to ship the product, right? You've already got your bug fixing something. Sometimes you just have to be willing to say, you know what? I'm just going to take the easiest way to get this shipped out the door, knowing it's not the perfect solution. Because there is no perfect solution, right? If we could come up with a perfect solution, we'd all sell it, right? We'd make billions of dollars on it. There's the good enough solution. And I think that the trick is, when you're a good architect or just a good developer in general, you can look at something and say, this is good enough. I'm willing to know what Jess was saying. I want to take on this technical debt because I will make sure that in the future, when that becomes a problem, I'm then going to fix that problem.
So how do you know what is good enough?
So
that was Chris's question earlier, right? How do you know when it's good enough? Because you just said when you are a good enough developer or a good enough architect.
So now we have to hire a good enough developer. And what is that interview like?
Right.
So, Mr. Snyder, I'm looking at your resume here. Are you good enough?
No,
like,
and in all
hard.
I have gotten multiple jobs.
Let's say
because I can explain patterns better than anybody else they interviewed. So I'm a good example of this.
No, I'm not good enough right now, right? Let's just say that I'm not good enough right now. How do I make working software?
Well, I would say is, in my experience, you need a good mentor. And in today's world, a good mentor isn't necessarily someone who works with you. There's lots of books and stuff out there. There's lots of examples. Hanselman always talks about this. Go look at other people's code, right? Immerse yourself in the world of the practice of creating.
No. That's making me better.
That was a good one.
Yeah,
that's making me better. These are all good tips. What I'm saying is, I am at my current skill level right now. I can't get any better, and I don't know how to just look at code and say, yes, that's good enough. That is over-engineered or under-engineered, which, as this whole conversation is saying, it's a subjective term in the first place. But how do I know when to stop or keep going?
Okay, so we use the word engineer, and this, to me, at least in my personal experience and opinion, is the problem. We need to think like engineers and not coders. When an engineer looks at the problem, he thinks, I have to solve this problem. How do I test it? How do I prove that it works? Right? What does a coder start thinking about? Well, I need ints, I need the long, I need to get this data from the database. I'm constantly thinking about the code and not the problem. So before I forget, I wanted to touch on this. There's a really great book. It's called Refactoring the Patterns. I've often talked about it. In there, that guy gives like 40 or 50 examples of, here's a problem. I use case statements. Case statements are the easiest thing to explain. I have a case statement with 3 cases. You know what? I don't need a strategy pattern. But the minute I got 5 or 6 cases, now I probably need the strategy pattern. So you have to be willing to look at it and say, you know what? Case statement, a couple is good enough. I can live with that code. But at the minute there's 45 case statements, then that's a problem. And to me, that's engineering. It's beginning to look at it and go, you know what? That's not testable code. Or that code is gonna have a problem. Because every time someone adds a new case statement, it becomes more and more, the technical debt gets higher and higher.
So I think
it's experience. I think it's really experience. I don't think there's anything else than experience. And having a good mentor, I think, helps you.
So I've heard those statements before. Things like, case statements are inherently dangerous or whatever, or even if the conditional statements, you should avoid them. That just sounds like very optimistic advice. Like you're really seriously saying, and I'm not saying you just said this, but yes, you're really seriously saying I should never write a case statement. Why is it even in the language then?
Well, that's like a whole other show, right?
Yeah.
We did one on nulls. Why not case statements?
But not just the case statement thing. Is that I think I just heard Mads Torgensen himself say during .NET Conf that you know, some things got into the language in 1.0, and we will forever pay for that sin, right? Like we can't get
Straight
rid
to
of
the
it, can't get rid of it, and and yet it's there. But I don't want to derail it too much.
Yeah.
The key is that we're not paid to use the entire language. We should be professional and expert enough to know what to use.
Oh, you're not paid for how much of the language you use?
Yeah, if we don't use if you don't use goto and labels and if defs, that's okay. That's cool. You're fine.
My bonus structure is actually around how
Totally
much
okay.
of the language
Yeah.
we use.
I
mean,
always
like,
throw in some unsafe code just for good measurement.
right. If you want to do
Yeah.
unsafe pointers and p invoke, we're not paid to do that, right? We're paid to
Yeah.
do.
Yeah.
But
I mean,
not to derail it. You're right. Like your point, Jess, was absolute rules are probably just as bad.
Yeah.
You should never use a switch. Well, wait, hold on. What? Really?
Yeah.
What if I'm really choosing between seven choices that have just minor tweak differences?
Yep.
You know, what am I supposed to do then?
Well, strategy pattern, clearly.
Write a
Yes.
factory. Yeah, clearly this is a factory.
So here's the thing. Back to Jess's original thing. I think the problem is most developers recognize that there's something they should learn, and they tend to learn design patterns first through a book, right? I went to the Gang of Four book, flipped through, and found strategy. I'm going to use strategy to solve all my problems.
Yeah.
Yes, right.
Books
Once
you
you
great.
learn it, I've got to spot it everywhere.
Yes.
Yeah, I agree.
You want to know what over engineering looks like? Read a design pattern book and then
Yes.
write some
Pattern.
code. That is going to be over engineered.
Right.
Exactly.
If you want to start on design patterns next year, then read the Gang of Four book. If you want to start next week, then go get head first design patterns.
Yes.
But either way, you're going to be searching for how to use this new hammer.
Yeah, exactly.
You're
It's
gonna be
definitely a hammer.
Because I did. I went through that phase.
Oh, yeah,
I
definitely.
absolutely did.
I used to love template methods. Oh, this is a template method. Feels great here. I can have a base class, even though I don't need a base class. Nope, I want a template method. I honestly think too, what I've learned is patterns are good as the tool in your toolbox, but the principles, particularly solid, dry, we talked about Yagni a little bit. Those are the things you really want to focus on. Because we were just talking a few minutes ago about languages. You know what? If I'm building a Java application or a .NET application, I approach it the same way. I don't care what the language does. I care about what I need to solve. So I need to build a bunch of classes that get to a database. Well, how do I abstract that away from my core code?
Yeah.
And the languages and frameworks are irrelevant or less relevant.
I will. Before we get too far, I want to throw in my answer to Chris's question earlier: is how do you know that you've over-architected? I think for me, you can tell a lot by trying to explain your code to other people, just in words, right? Over-architecture, whatever it is. I mean, over-architecture is the easiest thing, but just sitting down and saying, "Hey, this code does this, this line of code does this," not just lines of code, but actually follow the program through. And the more clicking, the more classes you need to jump to, the more interfaces you need to explain, well, this is here because this, and this, right? If you can explain it.
Pragmatic programmer, are you like the explainer to the duck?
What?
Which is a great story. Rubber
Yes.
duck debugging from the Pragmatic Programmer. There's a story in there. It's a great book. The show notes for this is going to be Amazon. Amazon's going to love us, and we're not Amazon partners or anything.
And we
How
should
to be an over-engineer.
A programmer carries around a rubber duck and debugs their code by forcing themselves to explain it line by line to the duck.
Yes, I remember that.
And you look at the duck, and the duck looks back at you. And to be honest, I haven't actually tried it with the duck, but I understand the feeling where the duck looks at you and goes, "I ain't buying it, man."
It's so that duck is so judgmental. I hate it.
Yeah.
Yes. So I use SciDuck when I write JavaScript code because that's how I feel. Oh, my head hurts. But I mean, there is, again, this, we talked about it a little bit before. Like, I try to do this to myself, right? When I look at something, I'm going, can I explain this to someone? And if I do, where am I going to stumble? Where am I going to start? Like, let's not pay attention to the actual thing we're worried about. We're going to go explain the 17 layers of stuff you need just to create the button.
No, but there is a difference between, explaining it to yourself and actually explaining it to someone, or the duck, but doing it out loud, putting it into words. Yeah. That freaking judgmental duck.
If your project uses a dependency injection container, do you find later that the developers have no clue how to change it?
Yes, sometimes.
So they just start making changes right in the concrete classes that you were injecting through some kind of big file. So now you've lost the whole point of the dependency injection container. So is that over engineering or lack of understanding? And is that the flip side of over engineering? Is developers maybe need a little to skill up a little on certain things, or do you just hate dependency injection containers?
I love dependency injection containers, but they could be a hammer if you're not careful.
Well, hold on. So there's dependency injection, the pattern, and dependency injection
Dependency injection
containers.
Well, there's
containers.
version
You don't need a
control,
con-
which is the pattern.
Right,
Dependency
well,
injection is the implementation.
dependency injection is an
Yes.
implementation, yes, but still, regardless of the pattern or implementation, you do
Like,
not need a container to implement the pattern.
Yes, right.
Yes.
I'll define a container as you've chosen some system. You've chosen
A framework to help you do
probably
it.
a framework off the shelf that you're even going to go so far as to say, I don't even know what DLLs I depend on at runtime. That's going to be injected by an XML file or some craziness like that. And what I've seen happen is the developers that are maybe not super familiar with it are scared of that file. They just go make the changes right at the call sites anyway, instead of doing what they probably should have done was new implementation, put it into the.
Well, and
So I
having
don't
that
know.
God file is a problem also. I mean, that's
Yes.
yet another smell, right? That's the central nervous system of your application, which is kind of a problem. Personally, for me, with dependency injection containers, I try to avoid introducing a container as much as possible. I try to introduce inversion of control, specifically dependency injection, as early as possible, constructor injection as early as possible, and try and get away with it as quick as possible, as much as possible, and usually just by newing it up in some central place of the application. You know, like in the global, app start or whatever
Yeah.
of my website, or the program main, the main
You
method
think of that
my
area
app.
as the host, or he's the
Yeah,
conductor. He's
yeah.
got to know how everything works
Yeah.
anyway.
Yes,
But then nobody else has to.
Right. And then when that central point becomes unmanageable or needs to be cleaned up, then I'm solving that problem of managing those dependencies by introducing a container.
So I'm looking for language features like if you open a project, and we'll just assume most everybody's main language of choice is like C#, but I guess we can even do a little JavaScript because that's pretty relevant to the working developer.
Oh yeah.
What do you like to see if you open a project? And I'm being a little vague on purpose because I want to hear some of your answers first. What are the language constructs you hope to see being used? And then what do you say, like, oh God, they're doing this, and I'll do something stupid like, oh, they're using regions.
Okay, so regions.
Red flag.
But that's just, now regions doesn't have anything to do with it doesn't have anything to do with the over engineering. But the reason I threw it out is as an example of, oh God, right?
No, it's a smell. It's an indication. If you have the overwhelming urge to put something in a region, that means it's too complicated and you're trying to hide it. It's almost like a psychological indication that
maybe if I just stick my head in the sand.
Yeah.
Tooling allowed you to do it, right? That's not even a language construct. It's more of a tooling.
That is. So I guess what I'm hoping to spend at least a couple minutes. We've talked a lot of great, like high level thinking and theory. Maybe if we could it would be cool if we could say, here's some concrete things to look for.
I got a list.
Won't succeed at this, but no, go ahead.
I got a list. Number 1, parameters to a function. I hate when I see more than 3. I don't always refactor it, but when I start seeing too many primitives, it makes my skin crawl. Long classes, long functions. If I have to scroll, that's bad.
Okay.
Up and down can be okay. If I'm scrolling left, that's really bad. And I've been in some code recently where I had to scroll left several times to find things. Yeah, that's a bad thing.
Out parameters, ref parameters.
Huh?
Out parameters, ref parameters.
I'm not a big fan of out parameters, but there are cases where.
No, sure, yeah, there are some patterns.
So what do you think about tuples then? What do you think about tuples?
That's a whole other subject for a whole other day. They feel nasty.
Like we don't want to use out parameters, so instead I'll return 2 things at once with a tuple.
I'm just going to jam them together.
Yeah.
Okay.
Yeah.
So I'm just curious.
I would treat it like that, right? If I have a function, like I'm going to add numbers, you know what? Maybe I need a bunch of primitives that deal with it. If I'm going to save to the database, I don't want to see a function for inserting data with 45 parameters or 25 parameters past it. That code is not maintainable. So that's a red flag. Parameter list. Function's too long. The other thing is, like Jess was saying, on the flip side, it's following the code, right? You all of a sudden, you've introduced 10 interfaces, and there's no value of having an interface other than you've created 10 interfaces, then it's over-engineered in that case. That's there's pros and cons on both sides. The other thing is duplicate code. I hate duplicate code. Like I said earlier, I'd actually make worse code just to eliminate duplicate code. There's nothing I hate more than scrolling down like, wait a minute, that same block of code was been in the same file 20 times already. That's just to be, it's, and I think a lot of it's to do with not developer laziness, is developers have a fear of changing the code. And Jess has done a great talk a number of times on TDD. And this gets back to be the whole, if you really want to do this stuff right, you've got to have those tests, because then you have the confidence. You know, I can change this code. It's okay for me to invest the few hours to clean the code up. Instead of just saying, you know what, it's too much trouble, copy that block of code down here and move on and go on.
And you prevent over-engineering because you've defined the tests. There's no need to write more code than just to satisfy those tests. That's the trick, or at least part of it.
That's part of the learning. Part of the learning. I think over-engineering, the real thing, is you just have to fall into it. Oh, I've went too far. Let me back off now. I ultimately think you have to write code, right? You can make all the pretty boxes you want in the world. If you don't write the code, do anything else. And I do something most people don't do anymore. I actually Visio a lot of stuff. If I'm going to put a function together, I actually try to put a bunch of Visio boxes and connect the dots and try to start to figure out, are there too many bots? Why do I have these things out here? But very few people do that anymore. And I'd only do it in certain cases, usually when I start.
Link to Visio in the show notes here.
Yes. Yes.
I
love Visio.
I'm going to challenge or deduplicate at all costs, because I think that can be a problem. That can definitely be over engineering, right?
I admit I have a problem with that.
Especially,
anonymous.
Especially if you get overzealous with it and something looks very, very similar, but there are subtle differences, or it happens to be literally exactly the same today, but that is just a circumstance, right? And tomorrow, one is going to change and the other is not. And it should be that way. I think that duplication is not necessarily evil all of the time. Though, if you find yourself duplicating things in a bunch of different places and it never changes in any of them, that's a pretty obvious place where you wanna centralize that.
So the good rule I've tried to adapt is never replace one line with 3 lines. If I've created something where I have to write 3 lines now to call that 1 line, I didn't solve the problem the right way. Right?
For me, it's all about telling a story, and not leaving anything out. And sometimes I mean that quite literally, meaning the words that you use in your methods and your variables. And when you can literally read it like a story, almost in English, that is the best thing to do. Very hard. And sometimes just shooting for that can tend to be over engineering, right? But that also, everything else that Todd had just started out by saying, you know, those parameters and everything, they kind of make that story a little bit hazy of what exactly is going on, or why am I passing all of those things in. One of the big things for me is avoiding side effects. And if you bring it back to that kind of metaphor of telling a story, it's like you're leaving out really important parts of the story, right? Stuff just happens and you never know about it. And then come to find out a couple lines later, oh yeah, this thing happened. Or more importantly, more dangerously, you assume that thing happened. And, you know, maybe it did, maybe it didn't. And sometimes it does. When you're testing it on your machine, it does. And then you run it in production and it doesn't. And so I think you want to be very explicit, and you want to tell the story very explicitly, with good contracts and everything. I mean, Todd mentioned the parameters; those are just all part of the contract. And spell it out.
I wanted to build upon real quick things. This gets down to the naming of a function. A function name should have a specific action and describe what it does, and it should only do that. Right? That's a good way to try to test for side effects. If your function is saved in a database, it shouldn't save the database and delete something.
And
as an example, and that's a very abstract example, but you could. That's part of the side effect. Is it's very easy to create these. I call it the we used to call it the DNA framework, but I don't know if that's really the best one. The 3 tiers, right? Everybody seems like they love 3 tiers. I have a presentation tier, a business logic tier, and a data tier. And the data tier ends becoming these giant like CRUD functions. That to me is a red flag there. Sometimes you need CRUD functions, but other times, like, maybe I just need to save.
Yeah.
Right?
No, and I think your example of save and delete is interesting too, because maybe that's what you want to do, right? Maybe that is your behavior, and maybe that's the behavior that you're going for. And so if it is, go ahead and put it in the method. Literally say that in the method. What does this method do? It saves and deletes. But you know what? The moment that you say and in a method name, that is by definition is saying that method does multiple things.
And that may be okay in some cases.
Maybe that's okay. Usually it's not. Usually you want to separate those things out. Usually you want to separate those things out and maybe throw in that third method that brings them back together.
Yeah, or you need a workflow class or something that sort of ties together.
Right. Yeah. I mean, and we're talking, this is an over-engineering podcast, and we just threw in a workflow class there. Took a simple one method and turned it into 3, and then added a workflow class on top of it. Clearly, that's not over-engineering.
To give you an example of over-engineering that I remember, you're right. It was the create update. It was basically a CRUD problem, but not related to SQL Server. It was related to a custom store of some kind. It's not really important what it was. And so I could almost see the developer working when I read this, as they said, creating is nothing more than getting something new initialized and then updating it.
Yeah.
It's essentially just a 2-step process. Just get something new and then call update on it. So in the ruthless pursuit of deduplication, what he did is said, okay, I'm going to have a base class then that when you call create, it'll then call new for whatever this type of object is, and then it'll call update right after that. And where it ended up being painful is that sounds reasonable, except what ended up being painful is the operation of newing ended up being slow.
Yeah.
I'm just going to use the generic slow.
Yeah.
And so it turns out that by throwing this in the base class, by telling yourself that this is implementation that I always want to be common, so I'm going to put it in a base class that everyone shall derive from, meant that a future implementer, myself, was stuck with that implementation. I was stuck with the idea.
I had to follow that same approach.
Yeah, I was stuck with the idea that making a new object was a create plus an update. I didn't want to make 2 of those network calls.
Well, and I would argue that violates my approach too. That method was not named properly. It was named create, but it was really a new and update.
It is, but it's in a base class, and so now as an implementer, I'm stuck because by the rules of this design, I have to derive from this thing.
Mm-hmm.
But I want a new implementation. I want to substitute the implementation. Now, obviously, there's ways around it. But that means let's say I get around it. I substitute the implementation. Well, now the next developer, do they know that I've done that? And you're beginning to, you can't leave signposts anymore.
Yeah.
So
well, that gets the whole other holy grail war of are base classes ever necessary,
right.
or they encode them.
Over engineering is.
It can be. In many cases, inheritance is over engineering, or it's adding a potential. Like you described the perfect example of. You've now set up a contract, right? And you coming later, you have the expectation you need to follow that contract. It's being very descriptive or prescriptive of how you need to solve the problem, when it may not always be the right solution. Yeah. But it's easy to make that mistake, particularly like a persistence layer, because you're like, I don't want to have this duplicate code, right? It's very easy to fall into that trap, and it's okay, but later on you refactor it. The problem is, I think ultimately all these things is no project of a legitimate size is ever worked on by one developer, right? There's teams of developers who worked on something over courses of years and years and years.
So developers on the same team, do they need to have a common approach to when they've over-engineered? What if you have disagreement? How do you deal with that?
Have a duel.
You have a duel?
Go ahead.
Solve the problem. Only one.
Only one.
The only one. Yeah. Okay.
I prefer the benevolent dictator approach.
Well, I feel like this is. Let's say you have a team of 5 smart developers, or I don't. I guess they don't have to necessarily be smart or not, but there could be real disagreement. Like I think this was too much. I think you did too much. I can't follow the code. It's over-engineered. What does that mean? Is that a cop-out? Is it legit? Do you reshuffle your teams?
I think it depends on the situation. I would actually, if this is something I really trust, I'd want to see his argument.
Yes.
Okay.
Yeah. Right.
And give me
yeah,
an alternative solution. Just to say, this is over-engineered. Okay,
You're right.
how would you have solved this problem? Let's
Right.
work it out on the whiteboard. And
You need to get on the same page, right? Maybe
Yeah.
the person who designed it, who implemented it, needs to explain it a little bit deeper. And if that doesn't solve the debate, if it's still being accused of being over-engineered, then the accuser needs to say, well, here's how I would solve this same problem in a simpler yet still, maintainable quote maintainable way. Assuming that's the goal. I mean, maybe that is their accusation, that this is, maintainable, and it really doesn't need to be because we're going to be throwing it away next quarter or something.
Well, then that's the argument. And that, to me, that's having a good, solid team of people to bounce ideas off. Like I said at the beginning about mentor. Mentors aren't necessarily always people with more experience than you. Heck, a lot of times I work with junior developers. I go ask them, hey, does this make sense to you?
Yeah.
Because you're going to want to ultimately implement a lot of the code. So if you can't, if I give you a good approach, but then you subvert the approach or don't follow the approach, then it's not solving the problem correctly. So it doesn't hurt to have competing ideas, but eventually you need to come consensus and build software.
Yeah, well, and it's never too late to change. I think a lot of it for me coming up with that right design it's constantly evolving. Sometimes, day to day, even when you're initially creating it, you're churning and you're really kind of coming up with that right design. I mean, there have been many times where I would go through a spike, and literally overnight, like one afternoon before I go home, I'll implement some interfaces or some abstract classes or something like that, and go ahead and implement a bunch of things that, and really flesh out that design. And the next day I'll come in and be like, wow, that's really unnecessary, like really overkill. Could I sit here and justify it to somebody? Yeah, but it's really overkill, and literally just go and delete them, right? Or I'll put in 5 interfaces when I say, well, yes, that is the true, that's the perfect design right there, but you really don't need 5. 1 will do. Just do that and move on.
Yeah. And that's where the languages can help you and hurt you in some cases.
Yeah, right. And then you leverage the refactoring to go and clean that back up and end up with somewhere in the middle, simplified from your overly complex, but still not overly simple or under-engineered. And
So
you gotta strike that balance.
Avoid over-engineering with a test-driven or test-first approach, or an approach where you're
proving your design's correct for the problem you're trying to solve.
You're not just writing
development's
code.
one way to do it.
Yeah, you're not just writing code. You're saying these code satisfies necessary tests and no more. Maybe a little more. That might be okay, but not a lot more. And then the other one is refactoring. And I think are we all in agreement that when we're using the term refactoring, we don't want to slip into that realm of redesign, which a lot of times at work, I've said it, a colleague says, yeah, I'm refactoring that code. And what they really mean is I have burnt it to the ground and I'm starting over, which is not the same thing.
Yep.
Because at least a refactoring is substitutable. You should be able to hit Control-Z after a refactoring, and the code, you could just go back and forth, undo, redo, and the code functionally works the same.
Yep.
But you've refactored to a pattern, you've refactored to deduplicate, you've refactored for whatever.
We're following the rules of refactoring as opposed to re-engineering, which is an entirely different thing.
Right, which is a different thing, and it's subtle, and it's a term we should probably do a better job with, because we probably are, like, not getting it correct. A whole bunch of junior developers never really understand that refactoring.
We're passing the bad practice along, or the bad terminology. I think the challenge is there's a good term, right? Refactoring become this overarching thing. Same thing with like design patterns, right? There's 10,000 design patterns. It's such a generic term anymore. It has less meaning.
Yeah, sure. Awesome.
I think one of the key drivers too is trying to break down complex problems so that they appear simple, or the implementation or the solution appears simple. and avoiding the opposite, taking some simple problem, simple solution, and just making it completely complex.
Don't add the complexity until you need it.
Yeah.
Which is hard. It really is hard.
So, did we nail it, or do we?
I think we nailed it.
Come back to it at a future date.
The one thing I wanted to talk about was loose coupling, the idea of loose coupling, especially in the context of things like Razor Pages and that debate that's been going on about, we accuse loose pages or Razor Pages of being not loosely coupled enough, and there are plenty out there who disagree with that. But I guess that's another show.
Yeah, I mean, I would always tab onto that it's when you look at a pattern, if you follow a pattern, it kind of forces you to follow a set of guidelines. Like MVC, right? I'm going to have a view, I'm going to have a controller, I'm going to have a model, right? But how many people make the model the data layer, right? Or how many people put up too much stuff in the view still? The pattern is only meant to be a description of a solution. There's no right or wrong way. You could implement the pattern wrong, even if you're using a pattern. The same thing with Razor Pages, right? There's a pattern there, and if you follow the pattern the way they expect it to, it's okay in some cases. It's when all of a sudden you put all the code in the Razor Page, then you've broken separation concern. So separation concern, I think, is, to me, that's the other principle we don't talk about with Solid, right?
Yeah.
It is to me the thing that really helps to learn. Just look at a problem and say, you know what? If I've given too much responsibility to this group of code, and how do I solve that problem? And then just start building upon it.
Well, I think ASP.NET MVC became more popular because it gave you a framework, and I mean that in the most generic sense, that allowed you to focus on one piece at a time. It allowed you to focus on the controller logic and the view logic or the markup or whatever, and the model one piece at a time, and then put them all together. Not that things like web forms or whatever didn't allow you to do that. You could, it seemed like web forms really encouraged you to put a lot of that stuff in the page. And I mean, I think the biggest problem with web forms is it's very difficult to test.
I think MVC benefited from coming along at a perfect time.
Yeah, sure.
It offered something that .NET developers were kind of hungry for, which was, I'm ready to take control of the HTML, CSS output now.
Mm-hmm. Yep.
Where in the web forms day it wasn't. So I'm not even talking about the pattern at this point.
Yeah.
Okay, and then the other thing it offered that I think it just came along at the right time to do this was, I want to start taking control of this. Crap, what was the other thing? Because it wasn't about the pattern, I think.
It was more about the flow, right? Remember, the whole page lifecycle was this complex.
I remember what it was. Remember, this was a time period when more and more web pages, they were beginning to give you user-facing URLs that looked like the music store sample.
Yeah.
So it was, and this wasn't just a .NET thing. It was becoming common. It was like the hot new thing of you go to a site and it was /doctors/6.
Yeah.
And since that was hot, they built that into that's routing. That's not MVC. That's routing.
Yes.
And yet those two things were attractive so they get put into the product, and then people switch over to it and they say, well, MVC must be the right way to build web pages. But if all you're doing in your controller, if you're doing one of two negative things, one of them is return view, well, then you don't need the controller.
Yeah.
Or the other thing is, your controller is actually calling the database, getting the answer, doing the business logic, and then pumping that to the view. Well, now that's not what you want to do either.
Yeah.
So I really feel like MVC benefited from offering developers control over their own markup at a time when the only other game in town was web forms, which took that away from
an alternative platform.
Well, and talk about over engineering. One of the things I loved about ASP.NET MVC is the things like action filters, right? Where you can tack on this behavior that's not even code in your controller. It's just you have a controller that's like 2 or 3 lines of code, and then 30 other things happen because you tapped it on through action filters. Yeah. Sometimes in like the global filters, not even like in the page, you can't even tell what's going on. And so going back to the idea of you have to be able to explain what's happening. If you're jumping around, oh, well, this thing happens over here. How are you supposed to know about that? I don't know. You just know because Bob told you, right? But but what always struck me as it always made me uncomfortable was exactly what you said, right? That the controller that returned view. And why the heck am I even creating a controller action if it just has one line and it returns view? And many times I'm just trying to find a home for it, right? And especially with routing, where attribute routing came along, where it didn't even matter where the controller action lived, what class it lived in. That didn't affect the route anymore. You could literally put an action in a class anywhere and just slap a route on it, and it worked. And so now I just put all of these pages in my home controller, right? Just because I needed a place to have them. And that was the perfect place for Razor Pages. And it was almost breaking separation of concerns there, because like, why is the controller getting involved just to say, hey, return a view? Why don't you just return a view by convention, right? But then you get into Razor Pages, and now you're putting logic into that page that was supposed to be simple.
But the reality is nothing preventing you
from your source. Even in Razor Pages, you can't you?
You can do anything in Razor Page. I can open a web client call.
You can, but so
I guess what I mean is you don't have to put the logic in the Razor Page. You could like anything else. You could say, well, I'm getting it from this library.
Yes, you can create a service, and you absolutely should.
That I've always had for loose coupling, like one of my metrics, one of my tests is, can I take this thing I've built and go consume it in another way?
A console app or something.
Just even a stupid console app, right?
Yeah,
can I consume it in another way?
Another platform. Yeah, take it from my web app and expose it in a WPF app. How much do I have to change it to consume my data access layer there?
Right.
No, absolutely. I use that same test too. But I think, it sounds like I was bashing Razor Pages again, but I'm not. So what Razor Pages has going for it is that you're on top of MVC, right? It's this abstraction now on top of MVC. So now we've got an abstraction on top of an abstraction, but maybe it's the right right level, right?
The fact that MVC especially in ASP.NET Core is a product name.
Yes.
It's the web server-side framework. And then now within the web server-side framework, we have choices. We have Razor Pages, we have the MVC pattern, and then we have features like routing and features like model binding, which I think they've done a pretty good job of saying we didn't bake those so tightly into the pattern, the MVC pattern, that you can then use them separately. Right. Theoretically, the three of us could get together and write a third way to consume this. We can come up with static void pages, Shazam pages, Shazam core or whatever, and we could, but then we could say, but we use model binding and we use routing, but we have yet another way,
right?
Which I mean, it's good. It's good. They're decoupling. They're breaking apart ASP.NET. Right?
Well, no, and to your point, one of the big selling points of ASP.NET MVC is routing, right? Routing is still exactly the same, and it's meaning it's the same engine. It's a different convention to derive the route, the URL, but it's the same engine. And ultimately, if you want to go back and start rewriting stuff, you can, using that same kind of rules and the same syntax as you do in an ASP.NET MVC, except now you're mapping it to a Razor page.
So to tie this all back to over-engineering, because they followed good solid patterns, they were able to introduce a new way of doing something to simplify it in some cases.
Or did they over-engineer the framework and then they had to justify it by adding another implementation?
Well, that's a whole other.
Right? How about this? In .NET Core 2, we have what are they called? The meta packages, because was it over-engineered that you had to you had to include 25 packages to do a new project, and none of us could memorize what they were. So now we're relying on the wizard. So they said, okay, fine. Here's a meta package.
You know what? But you're making fun of it. But is that not a legitimate approach, right?
Yes, it's a way
over engineering and then putting a layer
has to work. Yeah, you have to get to work, and it's so frustrating to say, well, why the hell can't I read my config file even? Oh, I didn't include Microsoft.ASP.config.config.die.die. Right, but no, I agree that it is a legitimate answer, because it can get you going. And then if you really are the stickler that says, I only want to ship the DLLs that I need to, all right, you put in the hard work then. Put in the hard work and figure it out.
Yeah.
What should that list look like? Because doing it the other way of saying, hey, now everyone has to understand what that list should look like was asking too much of all of us.
Although, do they do some kind of tree shaking or something where they're not actually bringing along the assemblies that?
I've never really, I'll be honest,
never
that I
gotten
haven't
into it.
figured out enough to say if that's when you go to build it, if you have to say something like, is there a switch?
Yeah, I need to look into that.
Because I think that's a good question.
Yeah.
Is, I want to ship the minimal project. I don't want to ship the over-engineered project. That's not really true. The overburdened, over dependency. It's not really over-engineering.
Yeah. All right.
All
And
right.
my closing note on this is that TypeScript is perfectly engineered.
yes, here
not
we go.
not
Yeah.
Unreal
Oh,
or
Everybody
Unreal.
should
that's
use
it, go there.
TypeScript.
This is perfect.
Now Todd should say something about WebAssembly.
Exactly. I didn't even see.
There you go. Let's
I
have
don't even have
Todd
to say
have
anything.
your platform. Go on. What
All right. And you, listener, have you
What
ever
do you think?
I can
over-engineered
talk about
anything?
SignalR, and I'll
Or have you had to work with something that's over-engineered? Or what are your thoughts on over-engineering? We'd love to know. Please leave a comment on the website, staticvoidpodcast.com. Not over-engineered. Staticvoidpodcast.com is not over-engineered. It is the least
Maybe it's slightly under-engineered, but it's definitely not over-engineered.
Or send an email to comments@staticvoidpodcast.com. And as always, if you have a topic you'd like us to discuss on the show, please feel free to let us know through those same channels. Chris, Todd, thank you for the chat.
This was fun.
And thank you, listener, for spending the time with us. We hope you enjoyed it, and we look forward to seeing you next time on the Static Void Podcast.